Hey guys, what we're going to do today is we're going to go through a couple of concepts that will help us to finish topic 2 of unit 2. These kind of don't really fit in anywhere, but they're just kind of random points that we need to make in order to be able to answer every single question. Once we've done that, we'll finish by looking at naming alcohols, which is incredibly similar to naming alkenes. So you'll be great. Don't worry about it. So the first thing that we need to go over is a concept about boiling point. Okay. So remember that the boiling point is the temperature that a substance boils at, obviously. Tends to be, if we think back to unit 1 and the bonding topic, it tends to be that the stronger the bonding or the forces in the molecule, the higher the boiling point. So things like ionic bonding have really high melting and boiling points because that ionic bond is strong and there's loads of them in the ionic lattice. Covalent network, incredibly high melting and boiling point. Because there's so many covalent bonds, and covalent bond is one of the strongest bonds you can get. In terms of unit 2, we're looking at consistently covalent molecular substances. So things like ethanol, where we've got our OH, all our hydrogens fitted around. These are all small molecules, okay? So they are small molecules. They have got covalent bonds. All of these are covalent bonds in the middle. But if you remember back to unit 1 and we talked about intermolecular forces, okay? If we have another molecule of ethanol, okay? These are weakly bonded to each other. So if we do a dotted line between them to show that they're very, very weakly bonded to each other, these are called intermolecular forces. That's why things like ethanol have a low boiling point. Ethanol boils at 87 degrees Celsius. That's incredibly low. And it's because these intermolecular forces are really easy to break. Like, it doesn't take a lot of heat in order to separate those out, okay? The important point that we need to know now is that the bigger the molecule, the bigger the intermolecular force. So ethanol has a fairly low melting and boiling point. If we added another carbon to each of those with hydrogens, this molecule is now bigger. That means the intermolecular forces are stronger between those molecules. Because the intermolecular forces are stronger, the higher the boiling point, it takes more energy in order to boil that substance. So what we can say, and we can say this for all of unit 2 essentially, is that the bigger the molecule, the higher the boiling point, okay? So if I gave you an example of which one has a higher melting and boiling point, ethane or butane? Well, which one is bigger? Butane has 4 carbons, whereas ethane only has 2 carbons. Butane is going to have a higher boiling point because those intermolecular forces are stronger, okay? That's just how we need to think about these molecules. Quite often you'll just get asked a question, a list of molecules, and it will say which one has the highest melting and which one has the highest boiling point. 2 ways to do it. You can either know that the bigger the molecule, the higher the boiling point, or if it's a little more complicated, sometimes they do try and trick you. If it's like an alcohol with one has 1 OH and one has 2 OHs, go to your data booklet and in the back there is a list of the melting and boiling points. If you do that just now, you'll need a data booklet anyway for the questions later on. So if you grab your data booklet, if not, there is a link to a data book, the online data booklet. There is a page in that has a list of the boiling points of different molecules, ethene, like propene, etc. And you can see it there. Okay. Second concept is something new to you, and that is what is called miscibility. Okay? If something is miscible, that means it can mix with water. Okay? So if you added water plus ethanol, that would mix. That doesn't separate out into layers. Okay? Whereas if you have water and oil, those don't mix. If you mix them, you can shake them as hard as you can. They'll separate out back into layers. This would be called miscible, and this would be called immiscible. Okay? There is a kind of rule about whether something is more likely to be miscible, whether it can mix with water. And this applies only to the alcohols and carboxylic acids. Okay? This is not about alkanes. Alkanes very, very rarely dissolve in water because they're so covalent. Alcohols and carboxylic acids, while also covalent, do have that OH group and the carboxyl group, which make it slightly more complicated. We don't need to know why that is at the moment, okay? But the rule is, the smaller the molecule, the more likely it is to be miscible in water, okay? Think of miscible as though dissolving for liquids. Can the two liquids dissolve into each other? Okay, so ethanol, incredibly miscible with water. It literally does not separate. Any alcohol, vodka, is literally a mixture of ethanol and water. It doesn't separate out. It doesn't turn into a water and ethanol layer. Whereas butanol, less miscible. Over time, it probably would separate out. Yeah, because it's bigger, okay? The reason is complicated. We don't need to know why. It's kind of to do with the more carbons there are, the more covalent of the molecule is. Again, don't need to understand that. That you learn a lot more about that in higher chemistry if you're going on to do higher. Okay, so boiling point. The bigger the molecule, the higher the boiling point. Miscibility for the alcohols and carboxylic acids. The bigger the molecule, the more miscible it is in water. Okay, so I'm going to pause the recording here so I can draw some molecules out of alcohols and then we can name them. Then that'll be us. We'll go to the PowerPoint. We'll quickly write a very, 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 very short note and then you can go on with some practice questions. Okay. Okay, so we have this alcohol. What we need to now do is name it, okay? So the rules for naming alcohols are the exact same as the rules for naming alkenes, okay? First thing to do is find the longest chain of carbons. In this molecule, that is this bit here, 4 carbons in a chain. We need to number the chain so that the alcohol group, that hydroxyl group, is the lowest number. We can number it 1, 2, 3, 4, or 1, 2, 3, 4. Okay, we're going to do it this way because that means the hydroxyl group has the lowest number. So 1, 2, 3, 4. Okay, we're going to name the main chain. So this is an alcohol, so it ends in the ol. 1, 2, 3, 4 carbons, so it's butan. And the OH group is on the second carbon. So the final bit of our name, can you guys see that? No, you can't. Is butan 2-ol, because the ol group is on the second carbon. Okay, that's the same as alkenes. If you remember back, you can name it but1-ene, but2-ene, which tells you the position of the double bond in that alkene. Okay, this is the exact same. Okay, once you've got that main name, you then need to just name any branches. So just let me get a different color. The only branch we have here is this one. It has 1 carbon in it, so it is a methyl group, and it's on the 3rd carbon in the chain. So that becomes 3-methyl butan 2-ol, and that's the name. Okay. Again, incredibly simple if you remember the rules for naming alkenes. Okay, so I'll pause again. I'll get another molecule, a slightly more complicated one, and then we can move on to do some practice. Okay. Okay. I'm sorry about the glare. I've only just realised that it's bad. I'm assuming that means it was bad last week. The lighting in my front room, it's awful. So we'll just have to deal with it. Okay, so another molecule, another alcohol that we're going to name. Okay. This time I've done the shortened structural formula, mainly because I didn't want to spend the time drawing out all the hydrogens, which is fine. So again, first step, find the longest chain. don't be tempted just to do the automatic thing that you think and just think it's a one straight line. No, the longest chain here is 1, 2, 3, 4, 5, 6. So it is a curvy straight line, curvy longest chain. Okay. Step 3, I've just missed a step. Step 2 is name the chain. So number the chain. Oh, I'm doing well this one. 1, 2, 3, 4, 5, 6, or we can go 1, 2, 3, 4, 5, 6. The OH needs to be in the lowest number, so I'm going to start at this side and go 1, 2, 3, 4, 5, 6. Okay, name the longest chain. That gives us the name hexanol, and the OH group is on the third carbon, which gives us hex and 2 all as the kind of main chain name. Then we need to just name the branches. Anyone who didn't point out or scream at the screen that should have been a 3. Be ashamed. The branches are here and here. There are 2 of them. They are both methyl groups because they have 1 carbon in them. There is 1 on carbon 2 and 1 on carbon 4. So that's, move that up slightly, 2, 4, dimethyl, because there's 2 of them. Ooh, run out of space. Dimethyl hexan 2O. Okay, simple as that. The rules are all almost the same. Naming alkenes, alkanes, and alcohols. There's only a tiny difference between the alkenes, alcohols, and the alkanes. So if you understand one, then you're more likely to understand the rest. Okay. What I'm going to do is I'm going to send you to part 2 of the video, which is linked in the PowerPoint, where I will go through the notes that I want you to write down. Again, I'll keep them as brief as possible because not the fun part. We'll do some practice questions, and then you'll see on the PowerPoint that the last task is to do a bit of creative work, make a poster explaining the differences between alcohols and carboxylic acids, since alcohols you haven't touched really since 3rd year, and carboxylic acid you just learned last week. So a nice creative task will help you get your head around those 2 different molecules. Okay. As I keep saying every week, make sure you keep asking questions. Always ask questions. Let us do our job. Let us help you. Okay. So go to part 2. I'll go through the notes. Thanks, guys.